Hi, my name's Liz, and I work for Museums Northumberland as part of the Our Past, Your Future project. We're really interested in finding out all about the STEM heritage of Newcastle, North Tyneside and Northumberland, and sharing it with you. We also want to tell you about some exciting careers that there are available in our area, and later on we'll have a special guest who'll be answering some of your questions.
In today's assembly, our special guest is Sally Poxon, a senior validation engineer, who's going to be answering your questions about her work with wind turbines. Before that, we're going to find out about some other careers related to renewable energy. Our first career is that of an electrical engineer. Electrical engineers design, develop and maintain electrical systems for buildings, transport and power distribution networks. On this diagram, you can see lots of different ways we can generate electricity. We can use fossil fuels, such as coal power stations, but we can also use renewable energy as well, so things like wind, solar, and hydropower. The electricity generated then passes along power lines, through substations, and eventually reaches our houses. Electrical engineers need to be creative to come up with the best solution to a problem. Because they're often working with a lot of other people, they need to be collaborative and share their ideas and listen to the ideas of others to work as part of a team. They develop and test new products and systems. Here you can see one running a vehicle test, and here they're testing a speaker. They often use computers to create schematics or diagrams of circuits they're going to use, and they can use computer programs to test out how well these will work. If you have a look at this diagram, can you recognize any of the symbols on it? There are lots of different types of electrical engineers. Some might have one specialism and they might install circuits or test them, whereas others might manage whole projects. Either way, they need to be organized to make sure that their circuits are wired correctly and that their products and projects are finished on time and to a high standard. Our next career is a solar energy engineer. They are experts in using sunlight to generate electricity. They use solar cells to harness energy from the sun's rays. This energy can then be either stored in batteries or connected to the national grid. Solar energy engineers need to be imaginative to work with clients to design, plan and implement solar energy projects for cities, businesses and homeowners. They also need to be organized to manage different aspects of a project. Here you can see a solar energy farm, and here you can see smaller panels being used on a roof. They're committed to improving renewable technology and keeping up to date with the latest developments. There are lots of solar-powered devices that you might see in your everyday life. You might have a solar charger for your phone or other device. You might have solar-powered lights in your garden, or even have a solar panel on your calculator. Our last career is that of a wind turbine technician. They install, maintain and repair wind turbines on land and at sea. Here you can see a turbine being installed on land. At sea can be a bit of a challenge. There's different ways that you could secure your wind turbine in place. You could secure them straight into the ground, but that would be hard in deeper waters. New technologies are being developed all the time that allow for floating wind turbines. These are secured to the ground at the bottom of the sea by cables and weights. To install a wind turbine at sea, they often use these jack-up barges, which are ships. They have what look like big ladders, and these go all the way down to the seabed and secure in place, and then the boat gets jacked up and helps them install the wind turbine. As well as installing, maintaining and repairing mechanical and electrical equipment on the turbines, they also have to monitor their daily performance. They'll need to be observant to make sure that turbines are installed correctly and find any faults and fix them. Wind turbine technicians are hard-working, and you need to be comfortable working at heights and in all weathers, so they need to be resilient. How do you think you would feel working at the top of one of these wind turbines? Our region is really important in terms of wind turbine technology. The first offshore wind farm in the UK was built off the coast of Blyth and consisted of 2 wind turbines. At the time, they were the largest offshore turbines in the world. They were decommissioned in 2019, but they paved the way for more offshore wind turbines all around the UK. There are currently 5 turbines off the coast of Blyth, and when they were installed in 2017, they were the first in the world to use gravity-based foundations. This means that they're built on land and then floated out to sea and sunk down. And this makes them easier and cheaper to install because they don't have to drill foundations into the seabed. As technology advances, turbines are getting bigger and more powerful, which means each one can generate more electricity. The next turbines to be installed near Blyth will actually be floating turbines. The North East is a key place for a career in the energy sector, with Blyth being home to a leading innovation and research centre for offshore renewable energy, and Newcastle College running an energy academy which will train the future workforce in the energy sector using qualifications from apprenticeships to degrees. Today's special guest is Sally Poxon, who is a senior validation engineer, and she's going to be telling us all about wind turbines. So hello, Sally.
Hiya, thanks for having me on.
Okay, so we've got some questions that have been sent in from local children who want to find out more about what it's like to do your job. So the first question that we've been asked is, what inspired you to choose this job and what training did you need to do?
Okay, so the thing that inspired me to be an engineer is I was always interested in how things work. When I was younger, I was always tinkering with little things and like trying to build little models of things. And like if my dad was taking something apart or trying to fix something, I'd always want to help, like, try and fix the washing machine or something. So that probably got me thinking about how stuff works. And also in terms of renewable energy, so I work with wind turbines a lot. I was really interested in sort of the green future about, when I was younger, people had started talking about climate change and how that might be a big problem in the future. And I was really interested in how I could do something good in that direction. So I was really keen to kind of work in renewable energy when I was older. When I was at school, I did my GCSEs and A-levels, and for A-levels I did maths and art and physics and DT, and the maths and the physics were really important to be able to go on and do my engineering degree, which I did afterwards. But the art and the DT were really interesting to go alongside it because they kind of provided a bit of a break from all the numbers and math stuff, and I could do something really creative. And being creative is really important as an engineer because you need to think of different solutions and have your own ideas about how something might work or how you can fix something. So I finished school and I went to university and I did a degree in mechanical engineering. And mechanical engineering is when you learn about anything that has moving parts to it, really. And so that was really really interesting. And at the end of that, I did a small project on looking at wind turbines, and I worked on a novel design, which just kind of means it's an inventive design, a new inventive design of a wind turbine blade. So that was a very exciting project to be able to work on, and that kind of led me to getting a job in renewable energy after I had finished university. And I think if you can see on these pictures, there's a wind turbine that's a very funny looking one with 3 legs on the bottom, and that's a wind turbine that I actually helped to build in Outer Mongolia. And I went to Outer Mongolia after I'd finished university just for a couple of months, and I was able to work on this small project which was actually about farming and how to water the ground in this really, really dry place. And so I was able to use all the knowledge that I had from university and all the skills that I'd picked up from like tinkering with little things when I was younger to help build this wind turbine, which actually was used to pump water out of the ground and then be able to water all the crops that they were growing.
Oh, brilliant. And it's a little bit different than the wind turbines we might see off the coast of Northumberland around here.
Yes, that's right. So if you're making a wind turbine for pumping water, then you use one that moves very slowly but is really strong when it moves. Whereas when you're making electricity, you use one that spins quite fast, but it doesn't have as much pull force when you spin it. Yeah.
Cool. That leads quite nicely onto our next question, which is why do we need wind turbines?
Okay, so why do we need wind turbines? I've already mentioned that I was interested in climate change from quite a young age. And so wind turbines are really good for giving us energy from a clean source. So we use electricity more and more every day. It powers things in our homes, it powers our computers, our mobile phones, our lights, but it also powers the factories which make things like toys and food and furniture, and it even powers cars now, doesn't it? So we use electricity everywhere. Now, we used to make electricity by burning something called fossil fuels, which is coal and other things like that. But we've now learned that they let out nasty gases into the air and they make our planet heat up. So now that we know this, we can decide to change it and keep the temperature of our planet at a normal rate, which will be better for everybody. So wind turbines just take energy out of the wind and make it into electricity, and they don't let out nasty gases. And when there is enough of them, then we can carry on using our computers and lights and cars without them having a nasty effect on the planet.
Wow, brilliant. So it does sound like an important sector to work in.
Yeah, definitely. And it really gives you a lot of motivation to go to work and do your best every day, because you know that you're doing it for a good cause.
Lovely. So one of the other questions that had been sent in was, have you ever been up a wind turbine? And if it was, what's it like?
So unfortunately, this isn't a picture of me on top of this wind turbine. I hope that one day I do go up a big wind turbine like this. It would be really exciting, and I'm not scared of heights, so it would be fine. But I have been up a small bit of a wind turbine, and inside there are lots of ladders to climb up. Some wind turbines do have a lift inside because some of them are very, very tall. There's lots of ladders or a lift, and they're quite small inside. They have to fit in a lot of equipment, which helps to make the electricity inside. Now, when I went up my small bit of a wind turbine, I was able to then abseil down. So I used ropes to get down the outside afterwards. So that was quite fun. But during my everyday job, I do go inside bits of wind turbines, and they're not connected to their towers. So they're just little bits. Well, they're quite big bits actually, but they're on the floor or inside our facilities. And so I go inside the blades, which are the bits that spin round on the wind turbine. Now, when I started at this company, which is over 10 years ago now, when you got inside the root of a blade, everything was sort of within reach. If you stood up, you could kind of just about touch the top, and you could just about touch the sides. But nowadays, they've got so big that if you put one on the floor outside your house and went upstairs, you still wouldn't be at the top of it. You'd still be able to see inside the blade. So they are really, really super big. And that goes for lots of different parts of the wind turbines. The bit that generates the electricity, the box on top of the tower, that's also sort of sometimes the size of a small house, I suppose. Yeah.
Wow, it's hard to imagine how big they are when you're seeing at them from such a distance.
Yes.
But the ones on land, you can get a bit more of an idea. But you've just mentioned that you go inside the wind turbines, and I know part of your job is testing them. And one of the questions that the young people sent in was, how do you test them?
So it's very important that you test wind turbines, and there's three main reasons. You need to make sure that they are safe, and so that when they are up and working and they're in the middle of a field or out in the sea, that they're not going to just fall over, or they're not going to have some sort of big incident associated with them. Now, you also need to make sure they work correctly, because it costs a lot of money to put up a wind turbine. And if you were going to put it up and then it just broke, and never generated any electricity, then that would be a problem for the person who put it up, because they need it to make some electricity. And then we need to have enough electricity for everybody to use. And the third reason is to make sure that the next time they design a wind turbine, an even bigger and better one, they can make it, well, they can make it bigger and better. And by so the results of the testing, they can learn more about what works well and what doesn't work so well on their wind turbine. So all the different parts of a wind turbine are tested. First of all, they're tested separately. So one of the things I'm quite involved with is testing the blades of a wind turbine, as I've already mentioned. And so to do that, I've got some pictures on the bottom of this slide here. This is a blade inside our blade testing facility. And you can see that the blade is on a big concrete structure at the end. That's called our hub. And we put it on there, and then we give it a big pull across the facility so it really bends. Now I'll just show you with my ruler what I mean. So it's a bit like we hold one end of the wind turbine blade here, and we imagine this is the wind turbine blade. We give it a big pull like this, and it really bends loads, just like my ruler is doing. And then we give it a bit of a wobble like this, and it makes the blade, it's like we're aging the blade as if it was sort of 20 years old. A bit like if you bend a paperclip back and forth, you know, it eventually breaks. Well, it's the same sort of idea. We do that with our wind turbine blade, and then after we've done that, we give it one more big pull at the end, and we've got to make sure it doesn't break, because it's got to be really strong even when it's really old and it's done all those cycles up and down. So that's one of the tests that we do. So the other bit we test is it's called the nacelle. It's the big box on top of the wind turbine that the blades connect to. And inside that is the bits that generate electricity, and there's also a gearbox in there. And that's got lots and lots of moving parts inside it. And so we have to test that to make sure that the parts will last a long time and that they'll work really nicely. Also that they don't get too hot, because that can be a problem inside wind turbines. So we do those tests. Those are the main things that I'm involved with in my job, but lots of other parts of the wind turbine are tested as well.
Fantastic. So the next question that we've been sent in is, what is the hardest project that you've worked on?
This was a really tricky question to answer. Now, the thing that I've chosen that was really hard to work on is with robots. So at the moment, wind turbines that are already up and working need to be checked and inspected every now and then to make sure that they're still going to work okay. Or there might be a problem that someone's noticed with them. And so somebody can go and check that out. Now, we're using robots more and more to do this work for us. There's a lot of reasons for this, but one of them is that it's quite a hazardous, that means sort of dangerous environment to go to. Particularly, you can see the picture in the middle at the top there, that's an under the water robot. And so it's quite dangerous to send somebody down under the water to go and check out some electric cables. And so it's great to get robots to do that. But the part that I needed to work on was to see how can we test these robots and make sure they're giving us the right answers. So we needed to come up with a test plan to say, if this robot can do this, can the next robot do that? And it was sort of to make comparisons between them, but we needed to make sure it was a fair test. And it was quite hard to work on it because it was a whole area I didn't really know anything about before. And so it was really interesting to learn all those new things about robots when I was working on it. And some of them are really clever. You can see at the top left, we've got some flying robots, drones. In the middle, we've got an under the water robot that would be remotely controlled by somebody on a boat. And the one on the right, we've got, I think it's called Bladebug. And it is a robot which goes and checks blades to check they are not damaged and they haven't been struck by lightning and things like that, that can happen to wind turbine blades.
Oh, lovely. And then the last question is, what was the best part of your job?
This is also a hard question, the best part of my job. I really love my job. It's so exciting to work in an industry that is really growing, and that, you know, wind turbines are getting put up everywhere all the time. And so it's a real kind of growing industry. I would say one of the most interesting parts of my job is introducing new test methods. It's really exciting to work on something that has never been done before. It kind of makes you feel a bit like an inventor in that way. Even if it's only a really small part of something, you know that you've kind of made a difference to that. Also, the people that I work with are really great. It's really fun to work in a team of people who are really excited to do their job, and you know, we're all got the same goal, to ultimately to do successful testing. So that's really great. Another thing that I was trying to demonstrate by this bottom picture here is that we use maths a lot, and it's really fun to use maths to solve real problems. And to be able to know that everything you've learned about maths is actually really useful, and has a really good use. Another thing that I do like is that the wind turbines that we work with are really, really big, and when I see one, you can kind of have a little think and a little celebration to say, I helped with that. Something that I did had an impact on that. And so that's quite a satisfying feeling, even if it's only a very small little bit that you did. It sort of helped to make something really, really big. And also just working towards something that is helping the planet. That gives me a lot of job satisfaction as well. The other last one I was going to mention was this picture in the right hand at the top. That's a tidal turbine. Now, tidal turbines, you don't see them because they're under the water, and there aren't very many of them yet. But hopefully in the future there will be a lot more of them. And it's quite exciting to work with tidal turbine manufacturers who are really trying to do inventive things that no one has done before. And also they're often quite small companies, so it's really great to be able to work with them and see them grow and become really successful companies too.
Oh, that sounds really rewarding as a job.
Yeah.
I had one more question, if that's all right.
Mm-hmm.
You mentioned, so you went to university to be able to do this,
Yes.
but are there other routes as well that people could take if they didn't want to go to university to begin with?
Yeah, absolutely. Yes, we have some people here at the Catapult who have started off as apprentices, and through the apprenticeship scheme have completed their apprenticeship and have gone on to carry on working here, but also may have been sponsored to do degrees after that, if they'd chosen to.
Oh, brilliant. Well, thank you very much for your time and answering all of those questions that have been sent in by students around our region. I know I really enjoyed listening to them, and I hope they did too. And thank you very much.
Thank you. Thanks for having me.
Thank you. Thank you for watching our assembly. We hope you enjoyed it. And thank you to all the schools who've sent in such fantastic questions, and to our special guest today, Sally Poxon.